Hello, geometry students. This is Mrs. Raposa. I'm just going to briefly explain to you some of the homework problems that were in the tangent ratio lesson for the Desmos activity you did. So remember that tangent is the ratio that's opposite over adjacent. So you should have this checked off for the very first problem. Tangent tangent of angle A is the opposite leg over the adjacent leg. Okay, let's go on to the next one. Find the ratio for the tangent of angle A. The tangent of angle A is going to be opposite, which is the opposite leg length, 45, over the adjacent leg length, which is 28. Remember, this is adjacent to that angle also. It's next to it, but this is the hypotenuse. It's not the adjacent leg. So the hypotenuse can never be used for the adjacent leg or the opposite leg. That's called the hypotenuse. That'll come up for sine and cosine later. So 45 over 28, that's what you should have for the second one. For the third frame, the tangent of angle B is actually the reciprocal of what you had in the last frame. The other one was tangent of angle A is 45 over 28, but now the tangent of angle B, opposite is the 28 and adjacent is the 45. So it should be 28 over 45. So let's go on to the next one. Find the ratio for tangent of S. S is down here. Again, this is the hypotenuse. I want the opposite leg length, 20, over the adjacent leg length, so 15. So 20 over 15 right here, which when you put into the calculator just gives you 1 1/3 or 1.3 repeating. Okay, that reduces to 4/3. So let's take a look at the tangent ratio for angle R. For angle R, this side is now the opposite of angle R. And this one is adjacent to angle R. So we turn that ratio for angle S upside down. It'll be 15 over 20. So 0.75 or 3/4 when you reduce it. Okay, let's take a look at the next one. Which equation, excuse me, can be used to solve for x? Well, the tangent of this angle right here, the tangent of 65 degrees, that's going to be the opposite length x over the adjacent length 9. So tangent of 65 equals x over 9. Let's take a look at the next one. Let's go about and solve that. So to do that, I have an answer key right here. This is frame 7. In frame 7, we set it up as the tangent of 65 degrees is the opposite over adjacent, so x over 9. And the tangent of 65 degrees, that's just a decimal approximation. You can go right to your calculator. Let me bring that up. And you can type in, before we type in the tangent of 65, let's make sure we're doing the tangent of 65 degrees and not the tangent of 65 radians. So I hit the mode button to get to this screen as Mrs. Gilbert explained in the last video. If radians is highlighted, don't want to find the tangent of 65 radians. You're going to learn about radians in another math course. That's just another way to measure angles. You can measure angles in degrees and radians, the same way you can measure lengths in inches, centimeters, feet, yards. There's different ways to measure angles. So we want to find the tangent of 65 degrees, so make sure degrees is highlighted. And then I'm going to quit out of this screen by hitting second mode to get to quit. And I'm just going to hit the tangent button, tangent of 65 degrees. Close the parentheses, hit enter, and that's about 2.1445. And that's where that decimal approximation came from. Ooh, got a noisy tractor coming by on my window. So the tangent of 65 degrees is equal to x over 9, means 2.1445 is x over 9. To undo division by 9, multiply each side by 9. And when you multiply these two by 9, you get 19.3 is about x. Okay, you don't even have to find the decimal approximation. You can just plug it into your calculator all at once. 9 times the tangent of 65 degrees will give you x. So let me show you that on the calculator. I'm going to clear this, and it'll just be 9 times the tangent of 65 degrees, and it'll give me the answer that I want. You can do it in 2 steps or 1. I still get 19.3. Okay, so let's take a look back at the Desmos activity over here. Okay, so we're going to go to the next frame. So so for that one, what was it? 19.3, right? 19.3 was our answer. So let's go to frame 8. Write an equation to solve for x. So you should have that the tangent of 27 degrees right? The tangent, oops, of 27 degrees, and I don't know how to put a degree symbol in this one, so I'm just going to put 27, even though it should be a degree symbol, equals the opposite over adjacent, equals x over 15. And that's what you should have for that one. And I'm going to go to the next screen. The answer to the previous, I told you what the answer is, now solve for x. So to do that, this is frame 9. I'm going to go back to my answer key, which is right here. Frame 8 and 9, the tangent of 27 degrees is x over 15. Just multiply each side by that denominator 15, and you'll get 15 times the tangent of 27 degrees is equal to the length we want. Or you could have found the tangent of 27 degrees first and then multiplied that by 15. So I'll go right to the calculator. So the tangent of, how many degrees was it again? Tangent of 27 degrees. Find that, and then you just multiply that answer. Just hit times 15. It'll give you your last answer times 15, or you can just do it in one swoop. 15 times the tangent of 27 degrees. You'll get the same answer. 15 times the tangent of 27 degrees. I'm just going to hit 27 on my keyboard, but again, 27, and you'll get the same answer, 7.64. So that's the answer for that one. Okay, let's go on to the next part. How do you find the perimeter of the triangle? Well, remember, we found out that x in the last frame, we found out that x was 7.64. So we just do a squared plus b squared equals c squared. And I think I have that right here. Yep. 7.64 squared plus 15 squared will give us the hypotenuse length squared. And when you do that all out, you should get about 16.8. So let's go on to frame 11. These are a little more challenging because the variable that we need to solve for is not in the numerator of the ratio, it's in the denominator. So in this side, you need to multiply by what you're dividing by. So multiply each side by x, and that will that's how you start that off. And then when you're all done, you'll end up with x times the tangent of 32 degrees is equal to 11. So you just divide each side by the tangent of 32 degrees. Remember, the tangent of 32 degrees, that's just some decimal number. I'm going to clear this all out. Tangent of, how many degrees was it again? Tangent of 32 degrees. That's just this decimal right here. So that's 0.624. I'm going to round to 9 because the next digit's more than 5. So you're dividing each side by 0.6249. There it is. And you just figure out what that is. You get 11 divided by that fraction will give you 17.6. I like this little trick. Let me go to the next page. Whenever the variable that you need to solve for is in the denominator, I kind of take this shortcut. Like tangent of 32 degrees is the same thing as tangent of 32 over 1. And we know that when you have two ratios equal to one another, the product of the extremes right here, these two multiplied, is going to equal this. So I just kind of take a shortcut. I just switch this x and the tangent of 32 degrees. So I just put the x here and the tangent of 32 underneath. So whatever's in the denominator of the ratio, you can switch with what's over here in the numerator. So anyway, it just becomes x equals 11 divided by the tangent of 32. I didn't finish this, but it was finished over here anyway. So it's 17.6. So, yep, 17.6 should be the answer we get for that. Okay, and on the last screen, you should have that the tangent of 58 degrees is equal to the opposite 10 over the adjacent x. So the tangent of 58 degrees is 10 divided by x, so that's what you should get for the challenge question. They just wanted you to write an equation. I mean, when you solve that, we can do it right now. Let's go to the calculator. What's 10 divided by the tangent of 58 degrees? So 10 divided by whatever the tangent of 58 degrees is. And I get about 6.25. Okay, hope that helped.